Thank you for attending this presentation. I'm Nguyen and I'm here to introduce you the new satellite that will be proposed to the NASA Flight Project Manager Candice Callisto. My project will be named as CAT, an abbreviated form of Climate Analysis Trailblazer, because our mission is to identify environmental changes in every region with high traffic and analyzed data. So we will cover some of the very basic calculation of the orbital. First, orbital velocity. So as we all know that the net centripetal force is equal to mass times velocity to the power of 2 total divided by radius. Gravitational force is equal to G times mass of Earth and mass of satellite together divided by radius to the power of 2. And in order to find out the orbital velocity, Fc equal to Fg, and we figured it out. Next, orbital period, which technically is the time the Earth takes to travel one cycle. We have the basic is velocity equal to distance divided by time. Since it's travel in the circular orbit, replaced by 2 pi times radius together divided by t. So the same with the orbital velocity, we let these two equal to each other so we can find the t formula. We did a little bit of research about at what altitude that the satellite will be safe, so let's take a look. Sorry for the typo of the velocity. The correct one that should be is kilometer per hour, because when I apply it into the graph it's more visible. You can see that it has the trend. The further it is away from Earth, the smaller speed it required to complete the cycle, and the altitude will be safe when in that range. We can find the orbital radius from the orbital period by moving the R to the left and the T to the right, like this. And as we all know that the Earth's radius is 6,071 kilometers, so if we use the radius that minus to that number, voila! So now let's move on to another exciting part. So as we know, to find the orbital missing elements in the GO satellite, I know that the orbital period, which is the time to complete its cycle, is in 23 hours, 56 minutes and 4 seconds. Therefore, I want my CAT satellite to complete its cycle in 5 hours, 2 minutes and 4 seconds, which I will go into apply it into my radius equation that I found previously, with the time converted into 18,166 seconds. Mass of Earth I found is 6.21 times to 10 to the power of 24 kilogram, and G after all converted the meters into the kilometer. Move on to the altitude. We are not done yet, because it is the altitude from the core of the Earth to the satellite. We have to find the altitude from the outer surface of the Earth to the satellite. The total radius minus to the radius of the Earth is like this, 6,731 kilometers, get minus. And move on to the orbital velocity. We also get the V1 we found previously, substitute in the numbers, the mass of the Earth and then the mass that we found, after get minus, and the V2 we use the mass that we haven't minus yet with the time 5 hours and 2 minutes and 4 seconds that converted to second already. We find that both of the answers are identical, which later we converted into 5.234 kilometers per second. I strongly believe that all of the equations and results I found are valid, because I made a mistake in the previous experiment that I forgot to square up one of the small equation, and that leads into all of the later equations are incorrect and in the sequence. That's pretty much all of the orbital issues that I solved when proposing the idea of the new satellite. I'd love to talk about the structure or engineering in the future about CAT project. Thank you and have a good day. 6, 5, 4, 3.